Every great system, like the platforms we rely on every day, all started from something simple. A single API, a basic service, just enough code to respond with "Hello World." In this series, we're going to follow that same path, starting small and building towards something powerful. Welcome to Journey to Microservices. And today we begin with the very first step, creating a simple Spring Boot API. Let's get started. For this series, we'll be consistently using a few core tools. I'll be working with IntelliJ IDEA Ultimate, but if you're using the Community Edition, no worries. Everything we're building will run just fine there too. Let's start by creating a new project and placing it in a single folder. I'll be sharing this later so you can reference or follow along. I prefer using Kotlin with Maven as the build tool. Let's name the project My First API, and we'll run it using Java 17. For the Spring Boot version, I'll go with the latest stable release, which as of now is 3.5.0. And finally, for our dependencies, we only need one key piece to get started. Let's select Spring Web. This enables our application to run as a web service, so it can handle HTTP requests and act as an API provider. Behind the scenes, it sets up the basics like a lightweight web server and the tools we need to build RESTful endpoints. But we won't have to worry about all that just yet. Spring Boot quietly does a lot of heavy lifting behind the scenes. First, it pulls in an embedded web server, usually Tomcat, so we don't need to set up anything external to serve our application on port 8080. Next, it sets up Spring MVC, which gives us all the tools to handle HTTP requests. Annotations like at REST controller, at get mapping, and automatic request routing are ready to go. It also brings in Jackson, so we can send and receive JSON without writing any serialization logic. Return a data class, and it just works. On top of that, it wires up input handling and validation, and uses auto configuration to connect all the pieces for us. No XML, no manual setup. In short, by adding Spring Web, we're fully equipped to build and serve RESTful APIs right away. That's also the reason why Spring Boot is a popular choice with developers around the globe. Before we dive in, here's one more thing. Throughout this series, we'll be using GitHub Copilot to help us move faster. Copilot will assist in writing boilerplate code, generating classes, and even suggesting configurations as we build out our microservices. Think of it as a coding partner that keeps the flow going, so we can focus more on the architecture, logic, and integration. It won't replace real decision-making, but it'll definitely save us time. Let's get into it. After everything has loaded already, I just simply hit run, and this should work out of the box. Although nothing is happening yet since we haven't added any logic yet. Let me stop the application for now and let's create a simple API to serve. Let's create a controller folder as well as a service folder. These are two important parts of any API. Let me explain some more later. Before anything else, let's see if our server works with some simple API. I have created a controller named Simple API just to demonstrate how a request will look like, and you can already see GitHub Copilot at work with suggestions on what to put here. Let's accept the changes and run the application. When you hit run, it will recompile the changes and deploy it on your local server. The new APIs we added should now be accessible. Let's jump to Postman and test the new endpoints. Create new HTTP request, targeting our local host server at port 8080 where it is currently served. And use the /hello endpoint. You can see that it is returning a response from the server. That's great. Let's test the goodbye endpoint as well before we go back to our lesson. Now that we've proven that APIs work, let us create APIs the right way. I mentioned earlier that controllers and services are key to API development. Simply put, controllers act as an entry point to your API server. This is where we usually put the HTTP methods, the routes, and the parameters that I needed to complete the API requests. Services, on the other hand, usually holds all the logic of your APIs from getting data from the database Computations as well as conditions needed to complete a request will be consolidated here. There are other parts that complete an API request, such as data objects for request and response, and validation rules, and classes that interact directly with databases. You will later learn how to group these components logically. Now we've created the user controller class. Instead of creating the request methods ourselves, let's utilize GitHub Copilot to generate RESTful APIs for this controller. I've selected the edit mode, which allows Copilot to directly integrate code suggestions. What we need to do is simply to select the context, meaning the files that are needed for Copilot to analyze before it makes intelligent suggestions. Then let's add the request message. After a while, you'll be able to see the difference between your current code and the suggestion that Copilot generated. You can take it by pieces or simply select Accept All. As you can see, Copilot was able to generate proper RESTful formatted API instantly. Even if the current logic and structure is not where we want, Copilot was able to create the blueprint we needed to work on. There are obviously some changes needed, like having your new methods communicate with the database, validations, and structure of your code. But overall, no complaints. RESTful API design follows this format. For one entity, he should have the basic CRUD operations, namely create, read or get, update, and delete. And it also follows a simplified format because HTTP method already holds the intent of what you need to do, and the naming clearly states what the service is for. Before we can start testing these APIs, there's one more thing to request from Copilot. We want to save time generating curl requests for our new APIs. So let's jump to the Ask feature of Copilot and get help with it. So same thing as before, we need to add the context files. In this case, the user controller and the details of the request. Now that we have valid curl requests, let's start importing them to Postman. Let's switch over to Postman, then click Import. Let's add all 5 methods and save them in a collection for later use. After importing the request, we can now start testing. As you can see, the getAllUsers request returned the 2 users that were generated by Copilot as mock data. Now, let's try to get one user using the ID. This should work as expected. Now, let me try to create a new user. Right off the bat, you can already see that this is not proper API format because we don't normally include IDs in the request form when creating new data. This ID should be generated in the service layer of our API, and we only need to pass the bare minimum information to generate a new user. But regardless, we were able to create the user successfully. Now, when we call getAllUsers API again, should be able to see the new user created as part of the list. And it worked. I just realized that the generated endpoints are using user instead of users. Let me correct it in the request, as well as in the code. I restarted my service after the changes. Now, let me try to get users with ID 3 and see what happens. I'm getting error 404 or not found. That means user ID 3 does not exist. Do you know why? Let's get the users again and see what's going on. There are only 2 users here. Because I restarted my server, my application reverted back to its original state, which only had 2 users at the beginning stored in cache. The user we added earlier did not persist because we were not storing in a database. The data only exists within our server. We'll get into connecting to databases in the next video. For now, let's try adding a new user again, and it's successful. Now, what happens if I create another user with the same ID? Let's try it out. We were able to create it. If you go back to get the users again, we will see that there are 2 users that have the same ID. This obviously is not expected, but the current logic of our code does not have any validations yet in place. That's why it's allowing this to happen. That said, update and delete will probably have behaviors that we do not expect. Let's try them. When we update the user's name for user ID 3, The application updates only the first instance of the user, and when we delete using ID 3, the API deletes all IDs that match. Let's refactor a bit before we continue with the lesson. I'm going to create a user service and move all the logic there because it is good practice to put all the logic in the service layer and have the controller handle the request and response only. I will ask Copilot to help me move these and also add error handling for the duplication on create of a new user. Let's review and accept the changes to both files. Now, because we refactored the code, it looks much cleaner now, and there is clear separation between the controller and the service logic. It will be easier for us to make changes later. Let me quickly retest the changes to make sure that the logic remains the same. Also, let's check if the duplicate error is now being thrown when we insert the same ID. And as you can see, we are now receiving an error for duplicate ID as well as the error code 409 for conflict. This is now much better than earlier. Now let's jump to the last part of the first chapter. The final lesson for this video is about configurations. Configurations are important for API services because it holds all the sensitive information you need for your environment. Here is where the application usually gets the dynamic information needed by your service. This typically holds the server configurations, database connections, encrypted password and secrets, as well as some additional properties that you need to modify to change some settings without having to rebuild your application. For example, if you need to update the port number where your application is deployed from, you can simply update the server.portconfig and restart your application. Let me create some personal configuration to show you how we can import this to the application during runtime. Let me create my .custom.name and my .custom.message. Now I will create a folder for config to load these in Spring Boot. I will create custom config and only put the parameters for my custom properties. I'll ask Copilot to help me add these correctly and quickly so I can avoid errors on what annotations are needed. Our configuration class is ready now. Let's start trying to load this in our application. Let's create an instance of our configuration in our main class. I'll try to show the content by printing out both the name and message in our terminal. After startup, both values are null. This is because the @configuration has not completed its loading process at this time and does not yet hold the values from config. Let me show you how to correctly load this and use it in our service. I will create a new startup service to show this better. And in this service, we will load the dependency of the custom config using the @autowired annotation. This process is called dependency injection. And this is one of the core features of Spring Boot. It simplifies adding dependencies using annotations to cleanly reuse an instance of your class. I will also introduce another notation called post-construct. This annotation is used to mark a method that should be run once, immediately after the bean is created and dependencies are injected. This is normally used to run some setup work after your server starts up. For now, I will just log the configuration to show that environment variables are taken and can be used in the application after startup completes. We can see the values now. We can reuse these configurations in the same way. We just need to make sure to load it as a dependency to ensure it finishes preload tasks before using in other services. This is also how database configurations load connections after startup. Finally, let's try to return this to an API. Let's return it in our hello endpoint. This is also an intro to how Cloud Config works. We will dive into that later in the series. Cloud Config is a way to expose configurations via an API for use of other services instead of having it in the application properties like what we have here. That will allow us to consolidate all configurations once we have dozens of microservices, multiplied by the number of environments projects usually have: dev, QA, UAT, production at the very least. Managing configurations in each project becomes difficult if we stick with this approach. I got an error 404, basically due to our change in the server.port configuration, which took effect as we restarted the service. after changing to 8081, and it worked. And we now get the value from the configuration as a response. And that wraps up the first chapter. With the help of GitHub Copilot, we got a lot done with less friction. We created a simple RESTful API with a user endpoint. We looked at how to use application properties for clean and flexible configuration. We introduced dependency injection, one of the core principles of Spring. And we implemented basic error handling to make our API more robust. This is but a small piece of the puzzle. We have a long journey ahead. In the next chapter, I'll show you how to connect this service to a database and use JPA connector for easy manipulation of data. Please like and subscribe. This will encourage me to dive further into the series. I hope the pacing and content felt just right. Not too fast, not too technical, but I'd love to know what you think. If you have suggestions on how I can improve the format, flow, or depth, drop a comment below. I'm building this series with you in mind. Thanks for sticking around, and I'll see you in the next one as we continue our journey to microservices, one step at a time. Until then, keep coding, and I'll see you in the next one.